Hi, boys and girls. I thought I would just talk through these slides with you just to help you kind of as a review of our electricity unit that we've had so far. So as we've seen in chemistry, matter is composed of atoms. So here's a picture of an atom here, and it's got a nucleus, and inside the nucleus are the protons and the neutrons, and buzzing around in the electron cloud are the electrons on the outside. So you guys remember that. I want to use the pen to point. Nope, I'll just be a pointer. Okay, so the next slide, if we look here, the positive protons are in this nucleus and they are locked in there with the neutrons that have no charge. They don't move around freely, they're stuck. But the electrons are moving around and they're the negatively charged ones and they're not locked. They're going all around. So the interesting thing about electrons is that they can actually move between atoms. They can be transferred through the material and they can move quite freely. So these flowing electrons, this free movement of electrons is what we call electricity. And we know that electrons want to go from the negative charge to the positive charge. All right. That's what we'll look at here. So what is electricity? Electricity is a form of energy made up of charges that can produce light, heat, or motion. Okay, so there is a law of conservation of energy, which states that energy can't be created or destroyed, but may only change form. This law applies here as the electrical charges can be transferred between objects. So the energy that's sent down here is being transformed into light and heat. All right, there are two types of electricity. There's static electricity. That's an electric charge that collects or builds up on the surface of an object. So some examples would be shocking, like if you're walking on carpet and then you touch a doorknob or somebody else and you do a shock, or lightning. That's static electricity. A current electricity is the flow of electron charges carried through a material such as a wire or other conductor. So some examples of that would be power lines, computers, appliances, anything where you're going to see electricity traveling through. So first we're going to look at the static electricity. Here's the rule number one. There are positive charges and there's negative charges. Rule number two, like charges repel and unlike charges attract. So these two positive here, they repel. Boom. The two negatives here, they repel. Boom. And then if they're unlike charges, they attract. So we have a positive and negative that come together. So like charges repel and unlike charges attract. So here's a visual of it. Right here, this one is moving apart because they're the same, and these two are moving together because they are opposite. So if we look at this, if I make this side positive and this side positive, they're going to repel. So each sphere has a positive one. If I reset it and I make this side negative and this side negative, what do you think will happen? Well, they'll repel. Let's reset this. So if I make this side positive, but I change this side to be negative, they come right together. So if they're opposite, they attract. All right. So with electricity, we have conductors and insulators. So conductors are any material that allows electrical charges to move through it. And so some examples would be metal, especially copper. Copper is a very good conductor, your body, and electrical wires. Now, insulators are materials that do not allow electrical charges to flow freely through them. So there's examples would be wood, glass, rubber, plastic. Okay, so this is just a fun little slide. When you switch on a light, the electricity passing through the cable is actually a flow of electrons. So this little light bulb plugs himself in and electricity flows through and lights him up. Here, Joey and Chandler from Friends are talking, and Joey says, "What? Is this how much we pay for electric?" Yeah. So he runs over and turns off the light switch. So there's no more electricity flowing through. All right. So charging an insulator caused by friction. Normally, atoms are neutral, there's no charge, and have equal numbers of electrons and protons. However, when two insulators are rubbed together, they create friction. Electrons may be transferred from one to another so that each is left with a net negative or a positive charge. So this girl right here has a balloon. It's neutral. It has 3 positives and 3 negatives. That equals neutral. Now she's taking the balloon and she's rubbing it on her sweater. So an atom becomes negatively charged when it gains an excess of electrons. So it's gaining all these electrons or these negative charges on this balloon. Similarly, when an object has electrons removed, it becomes positively charged. So the sweater is going to have a net positive. So in this picture here, you see the girl rubbing the dog. And so she is basically rubbing off the electrons. And so the hair is standing up on end. Okay. Also, an important thing to know is that there are electrical fields. So an electrical field is a region of space where an electric charge experiences a force, just as a gravitational field is a region where a mass experiences a force. So the arrows of the field tell us the direction. So here we've got a field of going away from a positive and going towards a negative. So electric fields are invisible, just like gravitational fields is invisible. We can't see it, but we can feel the strength of it. So here are some electrical fields. These two are drawn together. They're attracted to each other. The positive is going this way, and you can see that it's uniform. All of the lines are parallel that are attracting in the field.